This video was brought to you by the ILC. Hi there and welcome back once again. This is episode 32, and in this episode we're going to learn how to find the vertical asymptotes and the holes for a rational function. Let's get started. Our rational function this time is y equals 4x squared minus 16 divided by x squared minus x minus 6. We're going to try to find the vertical asymptotes and the holes for that function. The first thing you should do if you have a rational function is factor everything as much as possible immediately. It's going to make your life a whole lot easier. Let's start with the top. We have 4x squared minus 16, and you may notice that they both have 4 in common. Let's definitely factor out that 4. If we factor out the 4, we'll have 4 times x squared minus 4. Let's also factor the bottom. Our third term is negative 6, and our middle term is negative 1. Let's try to think of two numbers that multiply to negative 6. Well, 3 times negative 2 could make negative 6, but 3 minus 2 gives us positive 1. It's the right number, just not the right sign. So let's switch the signs. 2 minus 3 equals negative 1. That looks good. So let's break our denominator into x plus 2, x minus 3. However, we can factor the top a little bit more. You might notice this parentheses is x squared minus 4. That's all perfect squares. If you have two perfect squares and a negative in between them, you can factor a little bit further. Let's go ahead and do that. We should end up with x plus 2, x minus 2, and the bottom stays the same. Now that it's factored, let's talk about how you might get vertical asymptotes. If you're looking for vertical asymptotes, you're looking for something that is only on the bottom of the fraction and not on the top. We see we have x plus 2. It's on the bottom, but it's also on the top, so that would not be a vertical asymptote. We'll talk about that one in a second. For now, I do want to draw your attention to this x minus 3. It appears only on the bottom. This is what's going to give us our vertical asymptote. All we have to do is set that term equal to 0, which gives us x equals positive 3. This will appear as a dotted vertical line when we go to draw it. We'll talk about that a couple episodes from now. Now, look to this other term on the denominator, x plus 2. It appears on both the top and the bottom, and this is what's going to give us our hole. It appears on the top and the bottom. We'll go ahead and circle it. Once again, we're going to set this equal to 0 as well. We'll say x plus 2 equals 0. If we just move the 2 over, we'll have x equals negative 2. However, for holes, it's not enough just to find the x value. We are also going to have to find the y value. To help ourselves do that a little more effectively, we're going to go ahead and cancel out the x plus 2, since it appears on both the top and the bottom. So our y will be 4 times x minus 2 over x minus 3. I'm going to call this the simplified form. We'll simply replace the x with negative 2, so our result will be 4 times negative 2 minus 2 over negative 2 minus 3. If we do the math here, we have 4 times negative 2 minus 2 is negative 4. So on the top we will have negative 16, And on the bottom, negative 2 minus 3 is negative 5. Since they're both negative, we'll just change both signs. So our final answer for the whole has to be written as an ordered pair of coordinates. We place the x first, and then the y. The x was negative 2, and the y is 16 over 5. If you graph this, this will appear as an open circle. Eventually, our goal will be to graph this function with the information that we have here. We'll do that a few episodes from now. Next episode, we're going to get a little bit more information about this rational function so that we can graph it later. I'll see you there.